program on demystifying data for intelligent applications in real world scenarios. I hope yesterday's session enriched your understanding and sparked new ideas about the transformative power of data and emerging technologies. Your active engagement, insightful questions, and enthusiasm truly set a dynamic tone for this week long learning journey. Today, we continue to build on the momentum with another set of thoughtfully curated session designed to deepen your knowledge and expose you to advanced concepts and practical perspectives. We are privileged to have accomplished resource person who will share their expertise and guide us through today's topics. I encourage all the participants to remain interactive, ask questions, and make the most of this opportunity to enhance your skills, collaborate with peers, and broaden your professional networks. Thank you for your commitment to learning and for being an integral part of this FDP. Let us look forward to another day of meaningful discussions, valuable insights, and productive learning experiences. Wishing everyone an engaging and inspiring day too. Today's first speaker is Mr. Mrityunjoy Sen.
Sir, you are not audible. Not sure whether it's with me or others are also facing the same.
Am I audible?
Now it's okay. Yes.
Okay. So today's first speaker is Mr. Mrityunjoy Sen. Mr. Mrityunjoy Sen has been in the IT industry for 2.5 decades. Presently, he is associated with LTI Mindtree as Director, Digital Engineering Practice. Prior to LTI Mindtree, he worked with Cognizant, IBM, and Infosys and played multiple roles in different capacities. He is very passionate in learning and building solutions in the field of artificial intelligence and machine learning. So I would like to ask Mr. Sen to share the screen.
Okay. Thank you, sir. I'll. Is my screen visible?
Mm,
Not yet.
Not yet.
Okay. Is my screen visible now?
Yes, yes, yes.
Okay. So, sir, shall I start?
Yes, sir, you can start.
Okay. Uh, Very good evening, everyone. Uh, Before I proceed, I would like to thank IEM and sir, you especially for giving me opportunity to interact in this forum. So I will try to make next 1.5 hours effective, and the agenda that I am going to cover today's session is going to be an introduction of machine learning. Maybe some of you are already aware what it is, how it works, but objective of this session would be to make everyone uh, understand, like, how machine learning actually works, what we do in industry, and how we attack, and then we will try to solve one simple problem uh, with coding, which is going to be hands-on towards the end, so that you get a feel. Even if we talk a lot of things about machine learning, deep learning, generative AI, but on the ground, how it really works. What is it, right? So specifically, we'll cover in today's and tomorrow's session, one with supervised learning, other one regression under supervised learning, the other one the commonly used model that we use to solve real life problem is classification with hands-on examples. Okay, and at the end we can have a question answer session, or maybe once the my slides theory part is done, before I enter into the hands-on part, if you want, you can pause me and we can have questions, doubt clarified, and then enter into the coding part, if that is okay. Okay, so basically the agenda is introduction, then what are the different types of machine learning, what is supervised learning, then we will cover one very common type of supervised learning, which is linear regression, then one classification, and then we will enter into the hands-on part, and we'll use Google Colab to code and run the code and show how the results coming out. And at the end of the session, if you want, we can share the code base also for your reference and practice. Okay, so the first thing is, what is machine learning, right? It's that machine learning started long back, 90s, around 1960s. So that time it was, the concept was how we can make machine learn from data, past data, right? And this is the bookish definition of machine learning. Like, it's a basically field of computer science where we help machine to build its ability to learn from the past data without explicitly programming. What I mean by saying that is, so if you look at the traditional programming, the program that we write, what we do, it's basically set of instructions, right? Some if then else loop, and then for loops, all of this, and we exactly give the instruction what needs to be done, and what are our input, and then once the program is written, we feed data, input data, whatever logic or business rules we write through the set of programs in the code, that gets executed, and once the data is processed, we get the result. So result is the output, and data and program, these are my input. But in case of machine learning, what happens is, inputs are my data, which includes both the input information as well as data will contain the result. From the data, actually whatever program logic that we write, equivalent information actually is generated through the machine learning programming approach. So here, if you, the basic difference between traditional programming vis-a-vis machine learning programming is, in case of machine learning, my inputs are data containing may or which may or may not contain a result, but my output is the program. What I exactly mean by that, I will explain as I move forward. So basically what I said, it's basically machine learning is is a specialized area of an artificial intelligence. That is what is shown here. I'll cover in detail as I move forward. Now, why we should be learning, this particular area, why it is so popular and has become an emerging technology, is everywhere now machine learning is used. Specifically, if not the core machine learning, definitely a part of a specific type of machine learning, it is deep learning or some form of AI, generative AI is being used. Now, when machine learning started becoming popular, these are the few areas where we adopted, in early stage of the, this journey, AI journey. First was visual personal assistants, as you are aware, Siri, Alexa, Google Now. These are some of the examples. And if you look at the Facebook, right, face recognition, in some of the institutions, they use face recognition for their attendance purposes. And even social media sites, like, if you maybe have observed, might have observed that uh, if you upload a photo in Facebook, you will see, and then you tag, then next time onward when you upload a new photo, you will see that the person whom you tagged earlier, same face, machine, I mean Facebook is proposing you whether is that the same person you want to tag, right? So face recognition is one area where, machine learning is used widely. Then fraud detection, right? Transaction, whether primarily in the financial sector, banking and financial sector, or insurance domain, uh, there are a lot of transactions happening, and the volume of money involved in such some of the transactions are huge, and where, one fraud transaction once get approved, it's a huge loss of money for the bank or the institution. I will give you one example. You will understand how important it is. For one bank, person carrying same person with the same ATM card, two transactions happened, one in Boston, another in Texas, with a gap of only 5 minutes. Only 5 minutes. And you cannot fly from Boston to Texas in 5 minutes, right? So that transaction was passed. When analyzed, it was found that it's a fraud transaction, and then it was identified, how that time window can be 5 minutes, right? How is it possible? So so there are a lot of ways earlier fraud transaction used to happen, and now that because of machine learning and all, the moment you make such transaction, immediately it will be flagged, right? So and then once approved, then only it will take effect. Now, another example is a very common example you see is the spam mail filtering, right? In your mailbox, you see the spam mails are automatically getting filtered. So that is again an example of machine learning. And then, in the different retail site, if you log in, you will see that if you buy something, you will see the accessories. If you buy a phone, automatically the accessories will pop up whether you would be interested to buy those. So you buy one product, and then the similar products or whatever accessories they have will be recommended to you. Self-driven car is another good example. Uh, Detection of disease from medical images. So these are only a few examples where we are machine learning is used heavily, but it is not limited to these areas. Almost everywhere machine learning is now being used. There are 100,000 cases where machine learning is being used. Now, I will move on to the next point, that is the machine learning what are the different type of learnings that are involved. So how that learning happens, the way we teach a student or teach a kid, like we give the instruction, this is that, and then we keep telling, giving examples, we show them how what is what, and then how certain, if we tell a problem statement, then what is the output, what is how to solve it. Similar way here also we give the instruction to machine, but definitely in the form of data. So based on how we are giving the instruction to machine, so learning is categorized as supervised, unsupervised, semi-supervised, reinforcement learning, right? So supervised is a very popular type of learning, wherein when we in this type of learning, when we give the input, we also give the output, right? Okay, for this set of inputs, this is the output, and we give 100,000 lakhs of such examples, and from that example data which are being used for training purposes, machine understands what is the relationship between output and input variables, input attributes. And then next time, if you give a new sample, machine will, based on the learning, machine will predict what is going to be the output. Here, why supervised? Basically, the learning, that kind of learning that we are providing is under the supervision of somebody who has the knowledge. Here, who has that person? It is nothing but data. So data itself has input and output. So we will discuss, and there are different types of supervised learning. Very common to our regression and then classification. So we will talk these two in detail in next 1.5 hours. And the other one is supervised learning, unsupervised learning. In case of unsupervised learning, what happens is we don't provide output. We provide only the input set of data, and with that data, since we are not giving the output, the result, while we are training the machine, so machine can perform only some set of uh, can solve some type of problems. It can do something which is not under the supervision of anybody. Like if I give, say, few shapes, right? Few rectangle, few rectangle, few circles, like that. And if I don't say like which is what machine can, what type of solve problems machine can solve, machine will only be able to group the objects, similar groups in one cluster or one category, so that similar objects will be in one group, other type of objects will be in another group. So that kind of grouping or clustering type of problems that can be done using unsupervised learning. And then there is a reinforcement learning. It is based on decision making, like there we sometimes we learn on our own. If we go to a kitchen and if we touch a hot utensils, we will burn our finger, and next time we will not do it. So we will do things when I am getting rewarded. So it's basically reward and punishment kind of a stuff. So if you do something when you are getting punished, you will not do. So you will do things when you are getting rewarded. So basically every steps we are taking a decision, and through that process we learn a lot of things. So that kind of learning is called reinforcement learning. So we will discuss reinforcement learning, probably will not touch because of the time constant, but definitely we will cover supervised learning, regression, classification, and if time permits, tomorrow we will cover unsupervised learning, clustering also. So moving on to the next. So as I said, what is supervised learning? Here, if you look at, so we have different types of animals, right? So here, if the way we teach our kids, okay, this is dog, and this is, we show a image and then we tell it is a dog, and then we show another type of animal, multiple varieties of different breeds of dogs we show, and similarly we show the image of different cats and other animals also. And then if we then we ask, right, whether what is it, then if the answer is right, then we show another. So if I, the moment we see that kid is responding or answering properly, I able to identify the images properly, then we consider that kid has learned, right? Here also, like it's a data set that we provide. It is going to be a labeled data. So the image is input and the output is what this animal is. So whether it's a cat or dog, so that is also we tell to the uh, kids that, and that's how they learn. So here also same thing, like we follow the data set that we give to machine will have input as well as output. I will share one data set, and every will take that as an example and explain how it really works. But in case of unsupervised learning, what happens is, you see that here we have on the left hand side, we have birds, fishes, then we have animals, dog, cat, all of these. But here the images are not labeled. So system doesn't know, the data is not having, the data is not labeled. So which image is of what, that is not explicitly mentioned. So in such case, what kind of problems machine can solve? Machine will be able to only do, okay, if you look at, we see here there are three types of animals are there. One is bird, the other is fish, and then third is like four-legged animals, dog, cat, all of these. So they can group the similar objects together and create similar such multiple groups. So this is called clustering, and it is under unsupervised learning. And that is reinforcement learning. Will not spend much time here. We'll directly go to regression model. So machine learning, now the question comes, uh, can any problem be solved through machine learning, or we should solve certain problems through machine learning and then other problems should be solved through traditional programming? The answer is yes. Machine learning is not appropriate for any type of problems. Just because I have data available, I should solve all the problems with machine learning. No, that is not something what we should do. Like, I will give one example, things will be clear. What is the ideal candidate for as machine learning problem statement and what is not. Say, when you have something which, for which we know what is the formula, how to calculate the output, and we have defined logic available, like calculation of bank interest. Okay, so if I know this is the uh, principal amount and I want to invest for so many years, and then what is the interest rate, if I know all these three parameters, then I should not be predicting anything. Rather, I know the rules to calculate. I know the formula to calculate the principal, the amount in once the amount investment is matured, what is going to be my return amount. So that is something should be solved through traditional programming, because here we know how to calculate the maturity value. On the contrary, where we do not know how to calculate, if I am to predict what is going to be my, what is going to be the forecast for the sales volume for the next 3 quarters, this is something, there is no formula available. There is a lot of factors which can influence, and we don't know how to calculate it. So only way is, if I have a data of say last 10 years data, month wise data, what was the sales volume, and based on that probably we can train machine and then predict what could be my sales volume for the future months. So these are the certain things: predicting whether a tumor is malignant or benign, price prediction of a house or stock, demand forecasting, as I said, customer segmentation. So these are certain things which you really cannot solve by through traditional programming. Rather, we should solve this through machine learning. But these are the certain things like bank interest calculation, inventory management, customer onboarding, where we know how to do it, and there is a logic available. So these are the candidates to be solved through traditional programming. Now, to get into the, as I said, supervised learning, the most commonly used learning is supervised learning, and under that we have regression and classifications. So next 30 40 minutes we will spend on a regression model, how it works. So the example that we will take, it is basically say if the car manufacturing company wants to manufacture a new car, new model, right? Will that, is it recommended that company should you know invest money on design, and then once the design is ready they should directly jump into manufacturing, start manufacturing the car? The answer is no. Why? Because there are certain other things like CO2 emission. What is going to be the CO2 emission for that car being designed recently? So that is one aspect to needs to be checked, because there are certain government policies which every automobile manufacturing company has to comply with. So if the CO2 emission crosses some threshold, they should not start manufacturing unless it is rectified. So these are the certain things, but unless the car is manufactured and unless it starts running, how would you know that what is going to be the CO2 emission? So it's a catch-22 situation, right? Now, to solve this kind of problem, what we can do, okay, CO2 emission depends on what are the different parameters, what are different parameters which influences the CO2 emission. So if we know that, and if we can gather some information, like, okay, for the cars which are currently running on the road, what are those attributes for each of these models, and what is their CO2 emission rate? So from that, if we can make a machine learning model, train the model, and then whatever new design, new car we are going to design, or once it is designed, if we get all this information, then we can feed into the trained model, and then get to know what is going to be the predicted CO2 emission. This may be right, this may not be right, but if the model is model gives me some level of accuracy, 80-90% accuracy, then at least before I start manufacturing, I will be assured that, you know, probably 80% there is a chance that it will not fail in CO2 emission. So that is, these are the areas where, you know, from the industry perspective, they eliminate a lot of uncertainties through machine learning, through the AI, leveraging machine learning algorithms. So we train on the exist data with the existing cars, and then when we give the details of new car, it will tell us the expected CO2 emission. So we'll share more details, you will understand it better. So this is, I will take this data as an example. Okay. So here we have details of 10 cars. Okay. So what are the attribute which influences CO2 emission? There may be more, but for today's session, to make it very simple, I have considered 3 attributes. So these are the different attributes: engine size, cylinders, fuel consumption, and CO2 emissions. Out of these, CO2 emission is the output feature. Okay. And engine size, cylinder, fuel consumptions are my input features, and CO2 emission is the output. So if you consider the first row, if engine size is 2, 4 cylinders, fuel consumption is 8.5 unit, then CO2 emission is 196. So similarly, we have collected some data, though it is a sample data. Now, the car that I am going to manufacture, it is basically a design is done. Now we know that engine size will be 2.4 cc. There will be 4 cylinders. Fuel consumption is 9.2 liter per kilometer. So then from there, I need to predict what is going to be the CO2 emission. And if the once I get that, and then I can check with what is the threshold limit. And if it is well below threshold limit, then we can proceed with the manufacturing. So this is what, in this example, we will consider the first 3 row, first 3 columns, engine size, cylinders, fuel consumptions, as my input features, or we call it independent variables. So this, we represent independent variables with X. So engine size can be X1, cylinders X2, fuel consumption X3. These 3 are independent variables, and CO2 emission is my output. We represent, and we call it as dependent variable, because CO2 emission is dependent on engine size, cylinders, fuel consumption. So Y is dependent on X. That's why the output is also called, CO2 emission is the output feature, which is also called dependent variables, and the input variables X is also called dependent variables. Okay. Now, through the machine learning model, this data 0 to 8, whatever we have, row number 0 to first 9 rows, this data is already available, and with that data, this data will be fed into the machine, and we will ask you derive the relationship between Y and X. Okay. So what is the Y is definitely, since Y is output and X is my engine size, cylinder, fuel consumption, these are my inputs. So Y is dependent on X. So Y is a function of X. Now what is that relationship? That is something should be derived from the data. So that is the logic. The learning means nothing but you derive the relationship between input and output. Okay. Now how that is done? So before how that is done, we will cover that, but before that I will also spend a few minutes on what are the different type of regression models that are there. Okay, so first of all, regression is something where we are predicting something which is continuous, right? Which is continuous. Like here in this example, if you look at uh, output is, in this case its value is 196. It could be 196.5. It can be any integer, sorry, it can be any numbers which can be integer or float. So when the output that you are going to predict is numeric and it's continuous, then it's a case of regression. Okay, like if you see here, it is highlighted. Regression is the process of predicting continuous value using other parameters, meaning using the input features, you need to predict the output, which is in this case CO2 emission. If that output is a numeric value and it can have any value which is continuous, in that case we will use regression. But in case it is not a numeric value, or even if it is a numeric value but it can be some discrete values, say either the value could be either 0 1 or 0 1 2 3, only three, these four values it can have. So when the output values are discrete, then it's a case of classifications which I will cover in the maybe tomorrow, if time doesn't permit today. So but here in this particular example that we have taken, the CO2 emission is a numeric and it can have any value. Here the value that we are showing is integer, but it can be float also. So then that's why it is a clear case of regression problem statement. Now regression can be of two, primarily of two type. One is simple regression and the other is multiple regression. So what is simple regression? When your output variable y is dependent on only one input variable. So in our case, we have considered three input variables, which is cylinder, then fuel efficiency, and then there was one more. What was that? Engine size, right? So there were three. But if CO2 emission depends only on engine size, then it's a simple regression. If since the CO2 emission is actually now dependent on three attributes, three input variables, so it's a case of multiple regression. Now each of these, simple regression and multiple regression, are of two types. So simple regression, if it is the relationship between input and output, if it is linear, then it is simple linear regression. But if it is not a linear, it is something like, if you look at this graph, it will be clear. So if you look at this, so x is your input, y is output. So x and y relationship is linear, right? So it's a simple linear regression. But here, if you look at the second graph, the input and output, you see it's a curved line. So it's a non-linear regression. Hmm. Now, and then multiple regression is, but in this case, x will have only one attribute. But when you have multiple attributes, input parameters, then it's a multiple regression. But then again, if it is a linear, the relationship between input and output x and y, if it is a linear relationship, then it is called multiple linear regression. If the relationship is non-linear, then we call this multiple non-linear regression. So underlying, so in our case, if I consider that CO2 emission is only dependent on engine size, then we will have only one variable x, which we can represent like this: y equal to b0 plus b1 x1. So if we mathematically we want to represent any simple linear regression, because x and y can be only one variable x and y, and if it is linear, then the equation is going to be y equal to mx plus c, that kind of equation. And if it is a linear but multiple linear regression, that means we have multiple inputs like b0, then the mathematical representation of that equation between y and x is going to be like y equal to b0 plus b1 x1 plus b2 x2 plus bn xn. And similarly, if polynomial like non-linear case, it is going to be the power of the variables would be more than 1. So eventually when we say machine learning,
Sir, sorry to interrupt you. Just
yeah,
please click the hide option. The letter below is
okay.
not visible.
Sorry. Okay. Is it okay now, sir?
Uh, no, no, it is
Not.
not.
Oh, I just clicked and
Yes. It is okay. It is okay.
it is done. Okay.
Yes. Thank you, sir.
So now when we say that machine has learned, what essentially means machine actually has derived the relationship between x and y. Basically, machine has derived that equation, mathematical equation, okay, from the data. And that is exactly what we are going to show, how that is done. Now, the example that we have taken, okay, these are some of the example like where regression is applicable. So when we are forecasting sales volume or something, it is basically the volume that we are forecasting. It can have any value. It's a number. It will be a number, and it is going to be a continuous. That's why here it's a case of regression. Now, estimating the price of a house. Uh, so that is again, it can be 10 lakhs, it can be 10.5 lakhs, 40 lakhs, anything. First of all, it is numeric, and then again, it can have any value. So this is also a case of regression. And when somebody, with a set of experience on a particular technology, with if we know what is their educational qualification, and then we can predict like what is the salary that person can expect. So that is also, yes, and since it's a monthly salary or annual salary, it can have, it's a number and it can be any value. So that's also a case of regression. So these are the some example of the problems where we should apply the regression. Now, whether it's a simple regression or multiple regression, it depends, the output depends on how many attributes, whether only single attributes or multiple. Then whether it's a linear or non-linear, whether simple linear or simple non-linear or multiple linear, multiple non-linear, that will be decided if we plot the input versus output, then only we will get a sense. Right? I will show you as I move forward. So these are the different regression algorithms apart from what we just we discussed. We will come to this slide maybe a little later. So now the example that we discussed, I am coming to that and how we are going to solve this. So this is my y output and these are my input. So now we are going to solve simple linear regression. So since it's simple, meaning what? Output is dependent on only one input. So here we will consider engine size as my, even though in the data set, in this data, we have 3 columns, but for the time being, let's say that CO2 emission we are trying to predict with only engine size. So that then it is going to be a simple regression, but whether it's a linear or non-linear, if we plot engine size versus CO2 emission and looking at that data, then only we will get to know. But definitely it is a regression because we see it's a numeric value, output is a numeric value and it's a continuous. right? So these are the X is my engine size is my independent variable, and CO2 output is my dependent variable. Now, whether it's a case of simple linear or it's a multiple, it's a simple because we are considering only engine size, only one attribute. So definitely it's a simple. Now if you look at this, next thing is we don't know, looking at the data, we don't know whether it's a case of simple linear or simple non-linear regression. This is to get that idea which model is going to be applicable for this problem. We need to plot the data. Now engine size is my input, that's why it is plotted in x-axis, and CO2 emission is y-axis. Whatever data you see, it is, you see it here. Now it is looks like apparently it is a uh, if you look at this, it is apparently a relationship, most likely it is a straight line. Okay, now there can be multiple straight line like this, blue line, then red line, then a green line, right? But which one should I consider? Because eventually machine, from this data machine has to come up with the y equal to mx plus c, that. So CO2 equal to m into engine size plus some constant, right? So which line, we can draw multiple lines, but which line to be considered? Because we will consider every line, possible lines, and see which one is giving us the less error. But if we put engine size and corresponding from that line, we will calculate CO2 emission by plotting this. If you see that example, like say for 2.4, right here. So 2.4, if I consider the blue line, then this is going to be something less than 200 is going to be my CO2 emission. But if I consider the red line, you see for the same 2.4 CO engine size, it is giving me something CO2 emission, something which is greater than 200. Now then if I consider the green line is even more, right, giving me CO2 emission. So which one to consider? So we will put, will consider each and every line and put all these input values, like for engine size row 0 that you see, to what is the CO2 emission it is predicting. And then it is definitely may not be exactly same, it will predict something close to 196 or maybe 196 or close to 196. So we will calculate what is the error, considering all these lines, what is the error I am getting for the existing values. The line which will give me the less error, then we will, for each row we will calculate the error, and then we will sum up the error, and we will see what line is giving me the less error. uh, that line will be the considered as the best fit line, and that equation will be used for predicting any new sample. But how to calculate, how it is calculated, which line is giving the lowest error? Okay, so this is how it is going to going it internally machine calculates the error this way. I'm going to explain it. Okay, so whatever inputs that we had, we are going to calculate the error. Say for, if we consider x1, so actually machine, if you look at, this is x1 and y1 is the actual value. But if I consider this line, then this line will predict you this value, right? If you are able to follow the cursor, it will give you somewhere around this. So this yellow length that you are seeing, that is the error. Similarly, for all the samples, we will start calculating the error, and then we will, uh, calculate the square of that, and then we'll sum them up to see what is the total error. Whichever line gives us the minimum error is going to be the best fit line. and that equation will be the line equation of that line is going to be the relationship between y and x. Okay, so this is exactly, and there is a way, like, we have studied mathematics, right? um, uh, Maxima, minima, how to calculate differential calculus. So minimum effort the error is the function, and how, in which condition, for which value of y, m and c, in this example theta naught and theta 1, my error is 0. That is, for those values will be considered as the parameters, and then y equal to mx plus c is the line will be used, right? So this is how it is calculated. I will, so in this example, one example was there. I will come to this one quickly. Okay, now you will see. So the value that we just saw, for particularly this case, and this is the formula. If we use that algebra, the maxima minima, and then we calculate for which value of theta 0 and theta 1 my loss is minimum. This is the formula that comes up. So that way we can calculate theta 1, and if we put the theta 1, we take one example and put theta 1, and then theta naught can be calculated. Okay, so in this case, these are the values that is derived for this particular case. Hmm. And theta once calculated, if you put the value of theta 1 in the first line, you can calculate from there, you can calculate theta naught. So this is how it is calculated. I will show you. And then once you have that line calculated, y equal to mx plus c, or y equal to theta naught plus theta 1 x is calculated. Now you put the value of x, you know theta naught, you know. So this is how, for this particular case, you see it is calculated. Theta 0 and theta 1 is already calculated. So I see CO, and then in this example, if you look at this, CO2 emission is equal to theta naught plus theta 1 into engine size. And now you put 2.4, which is your engine size, then, and you know the value of theta naught and theta 1, which is theta naught is 125 and theta 1 is 39. And you can, from there you can calculate what is going to be your CO2 emission. So this is, so basically from data we are actually predicting uh, or we are deriving the relationship between output and input, and from there any new sample coming up, we can predict what is going to be the output for that, right? So this is how it is calculated. Okay, now with that, and so these are the problems. If we generally, what happens is, we, even though I talked a lot about, you know uh, calculating the error, and then you need to consider only that line which is giving you minimum error, so maxima, minima, all this calculation, but you don't have to do all of this if you use Python. So in Python we have uh, one package which is called scikit-learn. Scikit-learn provides everything, which I will show you now. uh, and with the scikit-learn we can solve these problems. Okay, uh, and how the, we will go to the code to get a feel. But how we do that, the data that you saw in my previous slides, so like this, I exactly have an Excel file. This one we will do the coding and you will get a feel. Okay, so this data will be used, say we have 0 to 8, that is 9 rows. uh, these, out of these 9 rows, what we do, maybe first 7, 0 to 6, we will use for training purpose. You find out the equation from using these 7 rows. In reality, 7 rows, in machine learning, nothing will happen. It has to be minimum, say 40, 50,000 records, okay, in order to make machine really learn and predict something, a good result. Minimum, bare minimum. But for learning, I mean, for this, discussion, for this session perspective, I have taken only uh, limited samples so that it is contained in the slide and we can explain it better. Now that here out of this 9 row, maybe generally what happens, we considered some 80% of the data uh, as my training data and remaining 2 as my test data. So when we ask machine to derive the relationship between CO2 emission and engine size, we give 7 rows. A machine comes up with some equation, and then row 7 and 8, around 20% data we keep for testing purposes. So that here we know when the engine size is 3.7, then my CO2 emission is this. So we provide this data to machine just to check, because I know for this input what is the output. And if I see that yes, machine is kind of giving me result which is very near to the actual value, then I am convinced, okay, machine has learned, the equation is more or less good, and I can really use it for my to predict the value for the new samples. Okay, till the time, and now say here for 3.7 it is 20, between 20 to 20, 255 and 267. But if you have given machine these values, first 7 rows, and then when you are asking machine to predict for engine size 3.7, and if machine predicts 150, which is far below 255, which is nowhere closer to that, so it is absolutely wrong. So definitely machine has not learned, right? So you cannot use this model for predicting any new sample unless you, then you have to consider like why the prediction was bad. It could be because you have missed, this is exactly what will happen, I will show you. uh, because here I have considered only engine size, I have not considered 2 other attributes as well. Okay, so definitely the accuracy will be pretty low. So now what we will do, we have a data set, I will show you. So this is the data set. Here I have total 10 rows. The data that you saw there, exactly similar data, but 1 row extra here. So this is the data we'll use for training. Okay, and we will see how machine is predicting. So that Excel file I have, I will show you. Uh, so this Excel file, let me share. Generally what happens is, if you use Google Colab, then you don't have to install the packages and all. If you have Gmail ID, then you can create a Google Colab ID and then use it for training. And exactly this is what I have done. Sorry. If you look at my Google Drive, what this is the. Hmm. So if you look at, see, I have kept this file data underscore CO2 emission underscore sample.csv. This file is kept in my drive, Google Drive, in this folder. So I just need to mount, first thing that I do in the Python code. I'll show the exact actual code also. Now, okay, let me first go to my slide. So basically I am linking the my Google Drive where I have kept the data set, that's CSV file where we have this data, and my Google Colab can understand or I'm trying to establish a link between Google Colab and my drive, Google Drive. The reason being, my file is present in my Google Drive. Okay, so this is the code that we do to mount the drive into uh, Google Colab. Second, I you need to import the Python libraries that are required: NumPy, Pandas, Matplotlib, and then what data we have. I'm just checking whether I'm reading that CSV file and then seeing how many records are all there. This is I'm reading the data set, and then next is I visualizing the data. So here, since it is a simple linear regression, I have considered, even though data set has 3 columns, input column features, but I am considering only engine size and CO2 emission. So, and then here I am plotting. So I will plot the points and see what is the relationship, whether it's a linear or it is a non-linear. Accordingly, I will use simple linear or simple non-linear. And then we need to split the data out of the 10 rows. I want to use 80%, 8 rows for training purpose, and remaining 20% 2 rows for testing. And then based on the testing, it will give me like what is the error that I am getting. What is the and if it is a satisfactory, so then we can proceed. Otherwise, we need to further work on improving the model, right? So this is the different steps, and here we are seeing the error part. So basically these are the steps. First, you drive. If you keep the uh, file in a particular folder, then you mount that drive. If it is in your Google Drive, you mount the drive. Next, you import the libraries that are required. You you read the file, your input data set. Then you visualize the data to check which model is applicable. It's a linear or non-linear. Third, you split the data set so that 80%, 75 to 80% data is kept for training, and remaining 20-25% is kept for training purpose. And next is now your training and test data set is now into split into two. Now you use the training data for train the model. This is exactly what we are doing. I will show you all these steps, and once that is done, you now print the line. So whichever is basically based on the training, actually machine will come up with which is the best fit line, and then you can plot that line and see what machine is predicting, what is the equation between these two lines. And finally, if you have, you can see what is you kept 20% of the data for testing. So you can check what is the error, what is the accuracy. For regression, you can use R2 score. You can check, other model like root mean square error also, but R2 score is a better one. Okay. So now with that, I will quickly show you the code just to give you a feel. Okay, simple enough. Reconnect. Okay, let me remove this. Just so. Okay, so as I showed, I'm just mounting the drive. This is the piece of code from google.colab import drive, then drive.mount. your content drive. So that way you are establishing the connection between the Google Colab and your Google Drive where you will keep your file. It is not mandatory that you keep the input file in a separate location, but it is recommended. If you want, you can keep the data set also in the same folder you have the Python code. That way you this particular piece of code is not required, but this is a good practice to follow. That is what we do in industry. So drive already mounted, that is good. Now here you will look at NumPy, Pandas, Matplotlib. These are the three. NumPy is for mathematical calculation, Pandas is used for data frames, and Matplotlib is to see the graphs and all. Okay. Now here I am reading the CSV file. And if, as I said, I have kept the files to my drive, then machine learning, then simple linear regression folder. There was a file called data CO2 emission sample CSV. And then I'm printing how many rows, columns are there, and then describe will tell you a lot of things about the data set. Right. So this is the thing. If you look at, so there are 10 rows and four columns. Okay. If you look at this 10 rows, 2 to 11, and there are 4 columns. So and then you can see what are the count. All columns is having values. There is nothing else. So that's what you said. If there is one particular cell is having none, no value, then you will see 9. So what is the mean value of engine size? 3.03. So these are some statistics. It is required for analysis purpose. Okay. And if you don't need it, then you can comment out this line and then run it. So it will not come again. So you can see only 10,4. And now here I am visualizing. So engine size is basically being, we are plotting it in x-axis wise and CO2 emission y-axis. And the dots are, every points are being basically represented by a red dot. So you can see, so basically engine size and CO2 emission are basically the relationship is like this. So we can consider it's a linear kind of a relation. And then so that's why we will apply linear regression. And since we are considering only engine size, so it's a simple regression and it is a simple linear regression. Then we need to split the data set. So I have 10 records, so maybe 80-20, we can make it 30-70, whatever. But it is better we use maximum data set for training purpose. So now these are the two records are used. If you look at in the row, and it will be system will pick randomly like which records it will consider as training for training purpose and which are the ones to be considered for testing purposes. But these are the random 6, 4, row number 0, 3, all these 8 are picked for training purposes and these 2 are for testing purpose. Now this is the main in code heart. Like here I am using the linear regression. This is a mathematical how we have to tell a system which statistical algorithm to use. Right? When as I said, it's a linear regression and it has only one parameter engine size, so it will use simple linear regression. Okay, so then it will know that it has to calculate only y equal to the relationship will be like y equal to mx plus c. So it has to calculate the value m and c. Like here you will see, so m is your m is your x intercept and y equal c is your y intercept or theta 0 and theta naught, right? So then that is also we are printing here. Now you see, if I run this code, so it is basically, so training is done and it is saying that y equal to 27.6 into x plus 145.99 or 146. That is the equation. And I am going to plot that. Okay. So what is the relationship? It is going to plot like this. So there will be some, it is not always, because my data is very few, only tens. If I would have considered 10,000, 20,000, you would have realized that the line is going to all, very close to all of these lines, all of these dots. So that error is less. And then if I ask how to evaluate the model, so I need to check, like in this case, the error is this part. If I consider for this dot, error is only this part. For this point, it is calculated exactly, it will calculate exactly same. This is good. So, but here also there is an error, here also there is a, but this line actually gives me the best fit line with the less error. Right? So this is how, and then if I calculate the, like, what is the you know error, mean absolute error is 35, which is pretty bad, pretty bad. Residual sum of square error, MSE 1499, and R2 score use is 65. It should be ideally close to 1, but it is 65. A very poor model. Training is done pretty badly. Why? Primarily reason being, we have considered only CO2, we are trying to predict only with the help of engine size, but CO2 emission here depends on other attributes also, which we have totally ignored. So that's why my output is coming is pretty low. Now same thing, if I do, I have the code ready, I will just quickly show you and then open the forum for question answer. So if I run these things here, the only difference is it is the same code, but in this data set, you see same data set being used, but here I have, instead of, here I'm going to plot it, but and here instead of red dots, you can change the color of the dots, like, you can make it blue, uh, anything that you want to, uh, and then if you want to split it, right? And here in random state, one means, like, every time it will consider the same set of records, but if you make it none, every time you run, it will give you different set of records will be used for training and testing purposes. Now it is 8 and 9, earlier it was 2 and 9. And then if I create the linear, here if you see, instead last time you considered only engine size, here I am considering engine size, cylinder and fuel, other two parameters also. So now I have having multiple features, input features. So it's a multiple linear regression. Okay. And now if I try to calculate the line, it is calculating, say, now the equation, what is going to be the equation? Y equal to m1 x1 plus m2 x2 plus m3 x3 plus c. So these are my m's value. M1, this is M2, this is M3, and this is my C. Okay. Now with that, we cannot draw the line because I have multiple X values. So I will not execute this code. Now, if I want to evaluate, then you can see, now you see mean absolute error and that residual sum of square. Earlier it was 1499, which is huge. And here R2 score 0.65. Ideally, the better the model, the result will be closer to 1. So if you see here, it is exactly 1. Okay. So this model now, with that, now if you can, in this model, if you give a new data sample, it will predict you mostly, which is going to be your close to accurate values. Okay. So this is how we solve the problem, machine learning. So basically, why it is important in today's context. So problems which we really cannot solve through traditional programming, we don't know how many if else, what is the algorithm, what is the logic to calculate the data. But if we have the data, then we can solve the problem. If we have existing data, past data, leveraging that, we can solve the problem. So that's the core of machine learning, and then that's the power of data, which can solve problems through machine learning. Okay, so with that I will take a pause, and I see only we have 10-12 minutes time. So if you have any question, please feel free to ask.
Sir, Devomita Sadhu has some question. Let
Hmm.
me allow the mic. Okay, madam, you can unmute yourself and can ask. Madam, please unmute yourself and ask. Devomita Sadhu, are you there? Is there any other question from the audience? Okay.
I think madam has said yes, I am. Yeah, madam,
Yes.
please go ahead.
Alright. Sir, in the meantime, I am
Hello.
having a yes, yes, yes. Madam, you're audible.
Yes.
Please
Yeah,
go,
I was
go on,
having
go
a
on.
technical problem. Yes, sir. Good morning. Good afternoon, sir.
Yeah, madam, please,
Uh,
good evening, go
uh,
ahead.
I I have a question. Uh, to understand machine learning and artificial intelligence and all of its sectors, someone needs to have an in-depth knowledge in mathematics because um, I did understand what you explained in this session, but I am if if there are any like any mathematics that is more difficult than this, like calculus and all, is that included in all of this?
Yeah, madam, I think it's a very valid question that you have asked. If you have good understanding of mathematics, definitely you will be able to correlate things better. Hmm. But is it that you need to know mathematics, and without that you cannot learn machine learning? The answer is no. You still can learn, because how exactly machine is learning things, how exactly it is working, so that knowledge, that you will be able to correlate if you have a good understanding of maths. But if you don't know all of this, can you still do it? The answer is yes. But probably lot of things will not be very clear. But things is, you have to practice more, like through Python code you have can solve problems. That, to solve any particular problems, probably without even knowing all of this, you should be able to do that. But there will be some complex problems where, if you have good mathematics background, then you will be able to solve those problems faster. But if you don't have it, probably you have to struggle a little bit. But it is not that you have to have a strong mathematics background.
Sir, actually, I had mathematics till 12th, class 12. But after that, since I studied BCA and MCA, I did not have much of difficult mathematics or advanced mathematics in the syllabus. So because of which I have forgotten some of the things. So I was wondering if that was going to affect my learning over here.
No, 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 it is not. Absolutely not. Only thing is, yes, I also started learning AI, specifically machine learning, 4, 5 years back. And I left mathematics 20 years, last, I passed out my higher secondary in 1994. Okay, and that was the
Okay,
time
okay.
and after that, and I started learning machine learning around 29 18 19. Okay, so there were almost 20 gap of 22 3 years when I did not touch mathematics. But still, whenever it is required, you can only just get a book, or now YouTube videos are available. You only study little bit about that chapter, and then you can continue. If you
Okay,
have
sir.
mathematics background, then it's good. As again, I will reiterate, if you don't have that knowledge, or you think that you have forgotten it, that's okay. I mean, you still can continue. You still can continue. And I will tell you at the end one YouTube channel which is very good, very good. You all,
Okay,
if
sir.
you have interest, you can refer to that.
Okay, sir. Yes, please tell me.
It's basically Campus X. I will show you. Others can take a screenshot. Like it's in Hindi, but it's very good.
Okay, okay.
So this guy, huh? Uh, Camp 100 Days of Machine Learning, Campus X. It's a YouTube channel. It's a big one, but small videos are there. And he has a channel of 100 days of deep learning, Python, if all of. Just a second, sorry. So this is the channel. If you see what is machine learning, AI
Yes.
versus machine learning versus deep learning. So he has a lot of videos. Only thing is you need to have patience to, and if you see 13 minutes, half an hour, there are very few which are more than 30 minutes, but most of them are 15 minutes, 20 minutes, 22 minutes, 30, like that. But he has
Yes, sir.
explained it very well, very well.
Okay, okay. Thank you,
Okay.
sir. Thank you very much for answering
Yeah.
my question.
Yeah. Okay. Any other question?
Is there any other question from the audience? Sir, actually, I have a question
Hmm.
that how can we ensure that the assumption of linear regression, like say linearity or independence, for real
Hmm.
world data?
Yeah, real world data, generally what happens is you have to plot the, like, in this case, what, what are your features, right? And you cannot have one single graph where you have multiple inputs and output, right? So, but what we do, say, uh, uh, we have three features. CO2 emission was dependent on in the data file. There were cylinders, number of cylinders, fuel efficiency, and then one more. So what you will do, uh, output versus all individual features. You need one x1 versus y. What is the relationship? You can plot through that matplotlib. Then you when you
Yes,
will,
yes.
since in my data set I had only 10 records, so it is not giving me the good visual effect whether it's a really a linear relationship or it's a curved relationship. But if you have say 100 200 records, no, then you will quickly, looking at the graph, you will get a sense which one is going to be what is the relationship. And if you see that all the features, say if you have 100 input features, then you can actually you have to plot each and every features, graph of each and every input features with the output, x1 versus y, x2 versus y, x3 versus y, all of them, and you will see if the majority of them are linear, then mostly you will get, it's going to be a linear multiple regression. Now then next step would be, but you just assumed that it's looking at that individual relationship, it seems to be a linear relation, so that's why you applied simple linear. Now when you go ahead and then train the machine and then ask machine to calculate the error, right? Because you have say 100 200 records in the data set, and 20% will be used for testing and remaining 80%. So if you have 200 records, so 40 records will be used for validation purpose. So when you will calculate the error, you will see your error is very high. If you select a wrong model, you will get error. Then you tried with linear, the result, the error that you are getting is quite high. Now you try, it is not, it is also trial and error method, because you took the decision of going ahead with linear regression based on individual parameter versus output relationship, but actually it was wrong. So you try the other one, non-linear, and then you see what is the error coming. If you see that error is you are getting less, the error value is low, R2 score is close to 1, that means in this case actually it is not linear relationship, it is non-linear. So basically it is not that you try one and it will give you the right result. Sometimes you have to try 2 3 models, and that's the thing that machine learning, based on the, since it's based on the data, for same set of data, one model will give you the better output compared to other models. But if anyone asks, like, which one is a better model, there is no such concrete answer that this model is better, that model is doesn't give result proper accuracy. Based on data, one model will be more accurate compared to the other models.
Definitely, that is totally data dependent.
Any other question?
Any other question from the participants? Okay, sir, I don't think there are any other questions. So thank you very much, sir, for your enriching and enlightening session, and hope to wish you tomorrow also at the same time. Thank you very much,
Yeah,
sir. On
yeah,
behalf
sure.
of the whole organizing committee, I thank you for your time and for your support. Thank you.
Thank you.